Radio transmitter and receiver. In this video, we are going to talk about how the radio waves are transmitted and received. What are radio waves? These are basically electromagnetic radiation, in which magnetic field and electric field and direction of propagation are mutually perpendicular to each other. In this electromagnetic radiation, the effect of electric field is nullified by the effect of magnetic field. As a result, the wave carries no charge. And this is electromagnetic spectrum. The visible spectrum lies between the wavelength of order 10 power minus 7 to 10 power minus 6 meter, where the wavelength of radio waves varies from 10 power minus 1 to 10 power plus 3 meter. Now we see about radio transmitters. A radio transmitter consists of several elements that work together to generate radio waves that contain useful information such as audio and video. Power supply. It provides the necessary electric power to operate the transmitter. Oscillator. It creates alternating current at the frequency on which the transmitter will transmit. The oscillator usually generates a sine wave, which is referred to as a carrier wave. Modulator. It adds useful information to the carrier wave. There are two main ways to add this information. The first, called amplitude modulation or AM, makes slight increases or decreases to the intensity of the carrier wave. The second, called frequency modulation or FM, makes slight increases or decreases the frequency of the carrier wave. Amplifier. It amplifies the modulated carrier wave to increase its power. The more powerful the amplifier, the more powerful the broadcast. Radio receivers. A radio receiver is the opposite of a radio transmitter. It uses an antenna to capture radio waves, processes those waves to extract only those waves that are vibrating at the desired frequency. It amplifies the signal and finally plays them on a speaker. Antenna. It captures the radio waves. Typically, the antenna is simply a length of wire. When this wire is exposed to the waves induce a very small alternating current in this antenna. RF amplifier. A sensitive amplifier that amplifies a very weak radio frequency RF signal from the antenna so that the signal can be processed by the tuner. Tuner. A circuit that can extract signals of a particular frequency from a mix of signals of different frequencies. On its own, the antenna captures radio waves of all frequencies and sends them to the RF amplifier, which dutifully amplifies them all. The tuner usually employs a combination of an inductor and a coil and a capacitor to form a circuit that resonates the particular frequency. You can adjust the resonant frequency by varying the amount of inductance in the coil or capacitance in the capacitor. Detector. Responsible for separating the audio information from the carrier wave. For AM signal, this can be done with a diode that just rectifies the alternating current signal. What's left after the diode has its way with the alternating current signal is a direct current signal that can be fed to an audio amplifier circuit. For FM signals, the detector circuit is a little more complicated. Audio amplifier. This component's job is to amplify the weak signal that comes from the detector so that it can be heard. This can be done using a simple transistor amplifier circuit. Of course, there are many variations on this basis radio receiver design. Many receivers include additional filtering and tuning circuits to be better locked onto the intended frequency or to produce better quality audio output and exclude other signals. Still, these basic elements are found in most receiver circuits.